So let's get going. So in the previous lesson, I basically looked at two types of questions. We looked at using trigonometry to find the length of sides and using trigonometry to find the length of angles. So I thought I'd start with just a quick little recap, nothing too long. Find me the length of the side AB and put that answer in the chat. Find me the length of AB. And I'm not going to give too many hints because we did this in the previous, and I just want to give you a little quick chance to consolidate that knowledge. So we're finding an unknown side in a right angle triangle. Then when you've got your answer, pop it in the chat. Or maybe if somebody is willing, you can just pop your hand up and talk me through how you got the answer to this question. Pop your hand up if you feel like you think that you could give us a bit of guidance on this one.
We love to hear your voices, guys, and we're very nice, so don't be shy.
And also we're learning, so we really just appreciate seeing your thinking. Otherwise, if putting in the chat is easier for you, you can do that too. But I really want to hear, like, how do you approach this question? So you know you need to find the length AB. What's your first move? What's the first thing you do? Okay, give me a thumbs up if things are going okay. Give me a thumbs down if you're feeling very confused. I just want to have a feel for the group. Because I'm going to go ahead and do it, but I just want a sense of if you're feeling confused or you're not. Or okay, so Nkosi says we're going to use tan. Yep, okay. So the way we do this is we say, look, we want to know what AB is, but that's the opposite. And we've got the adjacent. So what trig ratio uses O and A? It's going to be tan. And so we write the tan of 25. I can even do this with you. We write the tan of 25 is going to be equal to O. So what's O? So I'll call it O. It's fine. Over A, which is 12. And then because this 12 is on this side, we bring it across and we go 12 times the tan of 25 equals. And then what you should be getting is you should be getting 5.59 centimeters, or 5.6 if you round it off to one decimal place. And so this is how we solve for an unknown side in trigonometry. We often say we put what we want over what we know. So what we want is this one, and we know this one. So what we want over what we know, and then we write down the trig ratio and then the angle that's involved. Okay, so that's the first thing that we need to do with trigonometry. Then the second thing we need to know how to do is how to find a missing angle. So I'm going to give you that question over there, and I'm going to ask you to please try and find the angle X. So you've given a right angle triangle, and now it's similar but not the same. Okay, Cynthia, that's why it's always important to do revision here, and you're not the only one. It's like maths is like you build a solid foundation and then you build from there. And that's why we always go back and we make sure we've got the basics. Ayanda, why is adjacent on the side instead of down? That's a nice question, Ayanda. Let me zoom up a little bit just so we can do both at the same time. So in the previous question, the angle that we're given is this 25. And whatever side is opposite that 25 will be the opposite because it's opposite the angle we're given. Then the h is always opposite the hypotenuse. So that's this one over here is always going to be the h. And then so what's the only one that's left? Well, the only one that's left is going to be named a. And so that's why the a is going up. Does that help you, Ayanda? It's a very nice question. Thank you for asking that. Because normally when we're given the angle, a lot of the time it ends up down here. And so we get so used to it being here, we always think that this one over here is the opposite. Lovely question. Really liked it. Okay, so let's see if we can get the second one. Sia Takosa, let's go to your question. Can we unmute Sia Takosa? While the rest of our students are working on finding X.
Hi, sir.
Hello. How can I help?
So I got the answer for the second.
Okay, talk me through your thinking. What was your first step?
Firstly, I saw that in the triangle we are given the sides of hypotenuse and the opposite side.
Okay, so we're given H and O. Okay, and then?
And then I knew that we'll be using sine, so I said sine x.
Okay, sine x
is equals to 5/7.
Awesome, awesome. Okay, so you've actually given me a trig equation. But now what I really want to do is how do I get to this x over here?
We're going to transpose the sine to the other side, and then it will become sine to the power of -1.
Okay. Did you do that?
And yes, sir. And then we'll get the answer of 45.58.
Okay, 45.58 or 45.5 or 45.6, it was one decimal place, but we'll go with 58. Lovely. Thank you, Sia Takosa. That was wonderful. I just want to point out one thing. When we say this thing, this is called inverse sine or arc sine. We don't say sine -1 because sine minus to the power of -1, even though it looks like that, it reminds us of exponents. And this actually isn't an exponent. It's more of a notation. So you'll hear me say inverse sine or arc sine. And what that really does, it just means it tells the calculator to go the opposite direction. So you're telling the calculator, I'm giving you a ratio of sides. Please give me out an angle. Whereas a normal sine goes the other way. All right. Can we have a quick thumbs up or thumbs down vote? Do you feel like thumbs up if you feel like you understand these two basic skills? Thumbs down if you feel unsure about these types of skills. I'll just give a moment for everyone to get on the train and put their vote in there. Okay, that's good. So let's move on now to something a little bit different. So, well, yeah, let's look at the types of questions that in grade 11 you will face typically. So in grade 11, there's a couple of different types of questions that you need to be familiar with. I'm not going to do them all today, but I thought I'd just show you kind of where we're going. The first one is calculate the value of a trig expression without using a calculator. So that is this one over here. So we'll start working on those ones today. Second one, express trig ratio in terms of a given variable. We'll also start to touch on this with reduction formula. The third one is simplify a trig expression. The fourth one is prove a given identity. And then the final one is solve a trig equation for a general solution. So these are the types of questions that in this unit, we are going to be working towards mastering. Okay. Some people want me to zoom in a bit more. I can zoom in a bit more. Again, I'll come back to this later. I just wanted to give you the overview to start with. So these are the 5 types of questions that generally we need to build up knowledge for. If you want to take a screenshot, you can do that. But like I said, we're going to go through each type of question as we go through this unit. Okay, take a screenshot if you want to. 3, 2, 1, and go. Okay. So what I want to talk to you now about is something called special angles. Special angles. And this has got to do with finding the value of trig ratios without a calculator. So let's start with this shape. What type of shape is this? Can someone tell me in the chat, or somebody can tell me by unmuting themselves and coming on thing? It is a quadrilateral, but it's a special type of quadrilateral, isn't it? It's a square. Yes, it's a square. So we all know a square has equal sides with right angles. Okay, now let's take a square where the length of each side is 1, 1, and 1. Not very exciting, but it is what it is. Now what's going to happen is I am going to draw a diagonal across the square. I want to know what are the size of these angles, the red angle and the green angle. Can anybody tell me the size of the red angle and the green angle? You can put your hand up if you feel like you have the answer. You can tell me, or you can put it in the chat. But I'd always love to hear from you. What do you think the size of those 2 angles are? Or who can tell me how they know what size it is? Or what did they use to figure it out? Who feels like they know they can justify what they did? Hi, Faith. How did you figure out what the green and red angle are?
Hi, sir.
Hey.
How are you, sir?
Very good, Faith. Very good. Thank you.
Since it's a square, sir.
Yeah.
So each angle will be 90 degrees, right?
Yes, absolutely.
And so it is not divided into 2. So each of the angles will be 45 because the angles are divided into 2. Yeah.
Yeah, and they cut equally. These are congruent triangles. So they're cut in half. And so they each have to be 45. So you're right, the 90s get cut in half, which gives you 45. And so that's why each of these things is 45. Now, Faith, while I've got you, now that we've got the angles, I want to know what is the length of the hypotenuse, or how can I figure out the length of that diagonal?
I don't know, sir.
Okay, no problem. No problem at all. But I just wanted to ask the question. Thank you, Faith. Does anybody else have an idea that we could use to figure out the length of that diagonal? Because I'm not using trig. I mean, I could use trig, but see now I said, what about Pythagoras? Yes. So it's a right angle triangle. We could actually use trigonometry, but I'm going to ask you to use Pythagoras at this stage. Can I ask you to find out, I want everyone to try and find out the length of the red diagonal. I'll call that, well, I'm not going to call it anything. I'll just say red diagonal. Use Pythagoras and figure out the length of that red diagonal now. And once you know what the answer is, put it in the chat. So I'll call it, what should I call it? I'll call it D for diagonal. So I see lots of students are coming through with answers. So if I say D squared is equal to 1 squared plus 1 squared by Pythagoras, I think you'll all agree. And then if I say 1 squared plus 1 squared, well, that's 1 plus 1, so it's 2. And then if I square root both sides, I get square root 2, which is what everybody has been saying in the chat. So that is square root 2. Now, this is what we call a special triangle. And we can get it by just cutting a square of length 1 in half. So let's draw that, like pretend like we just have one of them. So it was like this, 45, 45. And then opposite that is going to be 1 and 1, and then root 2. So this is called a special triangle. And I want you to use the special triangle. I want you to tell me what is the sine of 45 using just the special triangle. No use of calculators whatsoever. We're just going to look at the special triangle. Tell me what you think the sine of 45 is. Let's go to Annie. Can we unmute Annie there? What do you think it is, Annie?
Sir.
Hey.
Hello, sir. Oh.
How's it going?
Sir, it's good, sir, and you?
Very good, thank you.
Sir, I think that sine 45 would be 1 over square root 2, because 45.
What did you do to figure that out, Annie? Can you tell us what you were thinking?
Sir, since sine is opposite over hypotenuse, and I can see that the 1 is opposite to the 45, and in the square root 2 is the hypotenuse, then I said that it's 1 over square root 2.
Yep. So the sine of 45 is 1 over root 2, and I don't need a calculator to figure that out. All I need to know about is the special triangle. And whenever I use that fact in a test or exam, I can just write this little triangle there, and then I don't need to use my calculator for this type of trig expression. Okay, following up from Annie's very helpful tip, I want everyone to figure out what the tan of 45 and what the cos of 45 is. I want you to work that up, but no calculators. I just want you to use the special triangle that we have just developed right here. And if you feel like you're willing to share, you can raise your hand or you can pop it in the chat. But we're just going to use the same idea that Annie just showed us now. Yeah. So it says here, aren't you supposed to keep a square root in the denominator? So Awam, you can what we call rationalize the denominator, but that right now I'm not asking that. All I'm saying is, can you connect the cos of 45 to this triangle down here, and can you connect the tan of 45? So Asipe has also put an answer in there. Yep, I think I agree with you, Asipe. And Cynthia, what do you, maybe you can explain to us how you got cos 45 and tan 45.
Afternoon, sir.
Hi, Cynthia. Can you help me out with this one?
Yes, I can. We all know that cos is equals to adjacent over the hypotenuse side. So
Yep.
the adjacent is 1 and our hypotenuse is square root of 2. That's how I got cos 45.
Exactly. And actually, it's the same as sine 45. So that's quite interesting, but it's true. Absolutely. And what about tan of 45? What did you get for that?
Tan is opposite over adjacent, and our opposite is 1. Our adjacent is also 1. So that's 1 over 1 equals to 1.
Perfect. So what we've done now is we have just solved a type of question where we've evaluated a trig ratio without using our calculator. And all we needed was the special triangle. And so, yeah, well done. Thank you so much, Cynthia. You were brilliant. So I want everybody to make sure you know the 45 triangle. Now, just because we've dealt with sine 45 and tan 45, we also need to deal with another type of special triangle. So let me go on and do that. So if I draw this shape over here, what is this shape over here? What's this called? Who would like to tell me what this shape is called? And what type of this shape is it? It's a triangle. Is it any type of triangle? No, it's an equilateral triangle. Yes. Now, remember that the other special angles I wanted to talk about today were 30 and 60. And so what I'm going to do is I'm going to find you a triangle that can help you with this. So I'm going to cut this in half. And if I cut this in half and it's perpendicular, I'm going to have a 90-degree angle. Now, if I want to know how long is the blue bit over here going to be? Any ideas? It's cutting this thing in half. How long will the blue bit be? Okay, it's going to be 1, as Sino has said and Bianca has said, because it's cutting the 2 in half. All right. We know that the outside bit here is going to be 2. What I want you to do for me now is, can you work out the height of this triangle? And I'm going to give you a hint. I want you to use Pythagoras. Can you use Pythagoras to help you find the height of this triangle? What is the height going to be of this triangle? So if I was using Pythagoras, I would say 2 squared is 1 squared plus h squared. And then 4 equals 1 plus h squared. I take away 1 from both sides. So I get that. And then h would be square root 3. So this thing over here is going to be square root 3. Now, this is great news for us. Well, here's the other thing that's really great news. Sorry, I hadn't filled this in. In an equilateral triangle, this angle over here is going to be 60, because in equilateral triangles, all the angles are 60. But I want someone to tell me, what is the size of the angle, which is a red dot? What size is that angle going to be? Using what you know about triangles. Yeah, it's going to be 30. Yeah, because it needs to add up to 180. So what we're going to do now is we have another special triangle. And sometimes the special triangle is written this way, sometimes it's written another way, but I'm just going to pull it out for today. And I'm going to write 60, 30. And what you'll notice is that the 1 is here, and the 2 is here, and then this bit over here is root 3. For me, I always remember that the 1 is opposite the 30. Now, I want someone to work out for me, what is the sine of 30 using this new special triangle that I've shown you? What is the sine of 30? And you may not use your calculator. What is the sine of 30? And we're going to have our break shortly. So in order to get the sine of 30, we look at our triangle and we say this is O, and this is H, and this is A. And so the sine of 30 is O over H. So it will be 1 over 2, because O over H. Okay. Here's your next question. What is the tan of 30 using this special triangle? What is the tan of 30 using this special triangle? I'll give you a little bit of time. I see it coming through. So for tan, it's over A. Sorry, so for tan, it's over A. So it's going to be 1 over root 3. Okay, now watch out. I'm going to be a bit sneaky now. What is the cos of 60 going to be? What is the cos of 60 going to be? And notice how I rubbed out the O, A, and H. I'll give you a hint there. Using your special triangle, what is the cos of 60? No calculators allowed. This is a sneaky one. So when 60 is the reference angle, the angle that's given to us, we know that this is now the O, this is still going to be the H, and this is going to be the A. So who would like to come on and give us the answer to this one? And then I think we definitely do a break. Who feels brave enough to give us explain how they did their thinking? Okay, so from what I see here, let's go to Annie. Annie, how did you do it? Oh,
So using what we've been learning so far, we know that cos is adjacent over hypotenuse, and the adjacent is 1 and the hypotenuse is 2. So we put it as 1 over 2, which is cos 60.
Okay. Now, did you notice, Annie, how the position of the O and A switched around? Why did the O and A switch positions?
Because the 60 and the 30 are opposite each other. So the 30, with the 30, the A, the 1 would be the opposite, and with the 60, the square root 3 would be the opposite.
So the position of the angle changed. And when the position of the angle you're using changed, the place of O and A also changed, which is great. All right. So in summarizing what we've learned about, there are 2 special triangles that we've learned about in the first part of the lesson today. The one is the 45 special triangle, and then the other one is the 60-30 special triangle. And the lengths that they have are root 2, 1, 1. And then for this one, it was like that. And so whenever they ask a question where it says you have to evaluate without a calculator, often you're going to have to draw these and you're going to have to use them. Give me a thumbs up if you feel like you understand those special triangles. Give me a thumbs down if you still feel a bit unsure about that. Just want to get a feel for our class. Okay. Right. So I can see it's a bit of a mixed one, but there's definitely some learning going on. And what I'm going to suggest is for those who feel confused, come back to this later, rewatch it, and see if it sinks in a bit better then. Okay, but now it is time for a break. So what I want to do is I want us all to stand up on our feet, and we are going to take some deep breaths, and we are going to just let our bodies click save as. Okay, turn on your cameras, everyone. Let's do this. I want to see all the happy people in the room. And what I want you to do is I want you to swing your arms around like you're a swimmer at the start of the Olympics, you know, when they're just loosening up and they're just swinging their arms, swing them around. There we go. Make your chest nice and big. And you are just swinging your arms. Okay, second exercise. You're going to rotate slowly at first from the hips. And then as your body relaxes, just turn yourself more and more. And then as your body's completely relaxed, you can go as far as you can go each way.
Look
Okay.
at all our people joining in.
Love it. Love it. Oh, doesn't your body feel good? Like all that sort of tired energy just drops away. Okay, let's do some circles. I love this one. I always feel like it gets my arms awake and my shoulder blades. So small circles, and then slightly bigger circles. And then big circles, like you're pretending to do the butterfly, which I can't do, but I pretend. There we go. Oh, all right. Shake it all out. Shake up those arms like you're a, I don't know, a puppet or something. And let's do a high heart rate one. Let's do jumping jacks. You just can't beat jumping jacks for efficacy. So let's do 10 and go from there. So on 3, so 3 or 1, 2, 3, 2, 3, 4, 5, 6, 7, 8, 9, 5 more. 1, 2, 3, 4, 5.
Every time.
I pulled the gym trainer trick. It's always good. But your body is happy. Come on, you know you are. Okay, and then for our little bit of a brain break, we're going to play this game called Maths 24. And you need to try and make 24 using these 4 numbers. And you can only use each number once. And you can only use the operations. Oh, you can tell my heart rate is up. Plus, minus, times, and divide. See if you can solve this one. Okay, I see people have put in the chat. So Brighton, I like where you're going, but if you go 5 times 5 minus 1, you've only used 3 of the numbers. So you need to use all 4. So Cynthia says 5 plus 5 plus 9 plus 1, that will give us 20. So we haven't got to 24. So we need to get to 24 using 9, 1, 5, and 5. What can we do? Oh, no, it's a 9 because you've got the bottom bit here. What can we do? This is a bit of a tricky one, eh? 5 times 6. What if we go? Actually, this one's stumping me as well. So if you assume it's a 6, right? So you're right. If it's a 6, you can go 5 times 6 minus 5 minus 1. But this is a 9 as far as I can see. Unless I'm misunderstanding this. But I think that this, what would I do? Can't do that. Okay. 5 times 6. All right. Well, let's go with that. But I'm pretty sure maybe that's a printing error. So we'll go with that for today. 5 times 6 gives me 30. So that's these 2 ones used. And then if you get 30 minus 5 minus 1, you get 24. And then you've used up everything. Although I'll check. I thought that was a 9, but maybe it's meant to be a 6. All right. Give me I'm not going to do any more today, but give me a thumbs up if you understand how Maths 24 works. Give me a thumbs down if you don't know how it works. Just want to check that out. Okay. It's a nice little fun exercise that we do. Inga, you were right, indeed. Well done. Okay. Let us return to our trig kind of lesson type thing. And I want to try a multiple choice question with you guys. So if we look at this, this is what we call a trig graph. And I want to know what type of trig graph is this? So before we even move on to the next stage, what type of trig graph is this? Okay, it's the sine graph. Yes, it is the sine graph indeed. And so what the sine graph does is it has angles along the x-axis. So you'll see here the angles over here. And then the y-axis has values. And the highest value that the y-axis gets to is 1, and the lowest value it gets to is -1. Okay, so you put in angles and you get out values. So then the question says, for 0 to 360, which value is equal to the sine of 30? So for 0 to 360, if you look at this graph, which value is equal to the sine of 30? And I want you to put your answer in the chat for me, if you can. Or actually, and the answer could be A, B, C, or D. Which value is equal to the sine of 30? Which of these 4 values? Let's go to Cynthia. Cynthia, what do you think?
So when you type sine 30 in the calculator, it gives you 1/2. And when you type sine 150, it also gives you 1/2. So the answer, I think the answer is A.
Okay, so Cynthia thinks the answer is A. Cynthia, your argument sounds very convincing. Does anybody else agree with Cynthia? Let's just have a look at the chat. So do we think the answer is A? Or do we think, what's the other answer? The answer was also sine of 330. So if I look at what Cynthia is saying, the sine of 30 in her calculator, she said was 1/2. And if I go to 30 degrees on my axis, can you see that 30 is indeed in line with 1/2 or 0.5? So now that's great, but I don't have sine of 30 or 1/2 as any of my choices. So what else might be equal to 1/2? And if I extend this across, you notice that the next time that the sine graph gets to 1/2, what x value is going with that? And it looks to me like it's at 150. So I want you to put into your calculator the sine of 150. And what do you get as the value? Do you get 1/2? Okay, so Tando says you got 1/2, which is great. All right. So this is an example of us getting angles where we can kind of go bigger than 90. Everyone else is getting halves as well. Fantastic. Okay. Now, this is a very interesting idea because all of a sudden, I can have angles that are going into trig ratios that are quite big. I want to ask you to use the graph now. I don't want you to use your calculator. I want you to answer this question for me. For what x value is the graph equal to -1/2? So when is the sine of x equal to -1/2, or when does at what x value does the graph equal -1/2? And have a look at the drawing and see if you can work it out from the drawing. And then you can put that in the chat. I'm ignoring the bottom part now. We're not worrying too much about that. I just want to know when is this graph, or what x values are going to give me the value of -0.5? So I was thinking, shouldn't I just go to -1/2 on the graph and draw a horizontal line across? And I'm going to get that point over there. Now, what value is that going to be? Okay. So we can say that that is 210, that the sine graph is going to be equal to -1/2 at 210. Now, there's another x value that could make the sine graph equal to -1/2. Can you guys find what that other x value is? So the other x value, you can use the voting, or you can put the number in. If I extend this, it looks to me like the graph hits -1/2 at that point. And so I'm going to go up, and what I see is that's going to be 330. And so we would say D is the answer that we were looking for, or it's equal to -1/2 at that point. Now, this is rather interesting. What this is telling me, and you can verify this with your calculator, that the sine of 30 is equal to the sine of 150, and those are both equal to 1/2. And then the graph also tells me that the sine of 210 is equal to the sine of 330, and they're both equal to -1/2, which is interesting. And I want to just ask you, give me a thumbs up if you understand how I could write that down. If I'm looking at the graph, give me a thumbs up if you feel like you understand where that came from. Okay. So to end the lesson today, what I'm going to say is that trig angles don't just have to be between 0 and 90. I've just shown you that trig graphs have angles that are bigger than 90. In fact, some of them are even bigger than 180. So for example, here we have angles like this, like 210 and 330. And those can't fit inside a triangle in the normal sense because they're bigger than 180. However, what we're going to do in the next lesson is we're going to start to look at something called the cast diagram and reduction formula to help us evaluate angles, trig ratios for angles that are bigger than 90. And just to point out the quadrants, when we summarize the behavior of the sine function, we talk about the quadrants, and we talk about how between 0 and 90 is the first quadrant. So let me go and find that. So if I go up to here, is the value of the sine graph positive or negative from 0 to 90? What do you think? Put in the chat, positive or negative. So it looks to me like it is positive. Yeah. So if we were imagining the cast diagram, if this was the first quadrant, 0 to 90, we'd say sine would be positive in this quadrant. What about from 90 to 180? Now we're looking at the sine graph. Between 90 and 180, is the sine graph positive or negative? Yeah, it looks to me like it is still positive because it's above the x-axis. Okay, but now, so we would say this quadrant over here is quadrant number 2, and sine is positive in quadrant number 2. Let's go and do quadrant number 3, which would be 270. Is the sine, in quadrant 3, is sine positive or negative? So it looks to me like in this quadrant, it is negative. So sine would be negative in this quadrant. And what about the last one? What about between 270 and 360? Okay, so we'd say it's negative. So this is quite helpful for us because we know that if we have the sine of an angle and it's between 0 and 180, it's going to be positive. But if it's between 180 and 360, it's going to be negative. And in the next lesson, we're going to do the same thing for the cos graph and the tan graph, and we're going to start to talk about how we can reduce these big angles to smaller angles. Okay, but I'm going to stop there for today because I think we've covered enough. Today we've covered some repetition. We did special angles, and we also did the beginnings of the reduction formula and trig functions. Lebo, could you put the link to the quiz in the chat? That would be awesome. And yeah, we're going to start to wrap things up. And yeah, let me know in the chat, how did you find today's session? Was it helpful? Were there some other things you still wanted to know about? Let me know in the chat. I'm always curious to know how the lesson goes for you guys, how it went for you. Fantastic. Yeah, I really do try to explain. Often I find with students that they learn the cost diagram off by heart, but they don't really know where the cost part comes from. And so in the next lesson, what we'll do is I'll show you why we write a C for this one, and then A stands for everything being positive. And we'll talk more about this. Okay, fantastic. Joy, let's go to you. And then Lembo, if you've got the link, you can just pop it in the chat. Oh, there it is. It's ready. All right, guys, if you're done for today and you feel comfortable, you can go and do the quiz, do the best you can. And I look forward to teaching you again on Monday.